Now I'm going to demonstrate the uses of spectrum in a capture. And I have a capture of a microwave oven at 50% power cycle, which means that it's on half the time, off half the time, and had captured with not only using the X500, with not only it's set to capture spectrum, but also capture Bluetooth devices, and then had selected for it to capture Wi-Fi devices. And so we'll analyze this. Now, spectrum shows up in the coexistence menu down at, or the coexistence view down at the bottom. And when we look at it, we can see that there's a timeline, and the orange means Wi-Fi, and the green means Bluetooth. And so we can see here, like in our summary view, we have green for Bluetooth and then orange for the Wi-Fi captures. And so the spectrum here is a part of the coexistence view to help see interferers and interference. And so what it's showing is the relative levels where blue is a stronger amount of interference, and then the white is weaker. And we can see here that you can look as you hold the cursor over it, you can see the relative levels in decibels. And this is the microwave oven. So it's 50% duty cycle. So you can see it's off here and then it's on here. And that what's interesting about the band, and we can zoom in either using the magnifying glass or zoom out. What I like to do is I like to use some of the preset options, and it's handy for spectrum. So in the United States, the power line is often it's at 60 hertz for the cycle, for the frequency, and 1 over that, so the period is 16.6 milliseconds. And I like knowing that because a lot of times the interference I see is in some way related to the power line. And one of my favorite preset options is 250 Bluetooth slots, because that is approximately 10 cycles of the 60 hertz power. And so if we zoom in here with that, we can see that if we count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that this interference is related in some way to the power line. In this case, the device is getting the power, the microwave oven's getting the power from the power line, and it's transmitting. It's interesting that it actually transmits along only half the cycle. What's also interesting, and is one of the important issues, since spectrum can cause issues with devices for capturing, either the device's transmitter could be causing interference, which you could see by if you would see coherent, like consistent with, let's say, Bluetooth packets, and then leakage among the spectrum. The other thing is, if you're trying to mitigate the interference, knowing what the environment looks like and being able to characterize this is important of the spectrum. So if we scroll along here, we can see that this is interesting with the microwave, because we can see that it has different patterns when it's transmitting. And so being able to characterize this and measure it is useful. And the option to do that, to be able to look at this spectrum map without the other data, is to use the export and then spectrum data. And you have a couple options, either the timestamp or relative time. And we can capture we can export the spectrum for the entire file, or on just a selected time range. And so I like this one a lot of times, because that's going to be the selected view for the window. There's also an option between packets. So if there's particular packets of interest where there's interferers that you want to capture, you could select the packets either from the summary menu or from here, and then use this option would be highlighted. I'm going to choose where to put that. I'm going to put that in the data directory. So there's nothing right there. And we'll export that. And then when we go to look at it, go to the share. And right over here. Then go to data. And here is the spectrum we exported. While that loads, just to show you. So while the spectrum axis here, it's time along the horizontal and then frequency along the vertical, the 2.4 gigahertz band. When you load it into the spreadsheet, we have our time going along the vertical axis. So each row is a particular instant in time. So it would be one of these columns. And then frequency, and these are the frequency bands that go along the horizontal axis. And this is the 1 megahertz bands. And so then you now have these dB attenuation or amplitude values in dB that correspond with when I'm moving the mouse here. And now you can make quantitative measurements with this. The other option, besides using a UI to export particular features of interest, is automation. And that's what we will look at next.